Hi there! Today I'm going to show you how I set up the camera system on my Thunder Laser to work completely wirelessly. Look Ma, no wires. So this project's actually going to start quite differently than other projects on my channel, in that we're starting on the computer and not because we're doing a design. The brains of how this whole wireless webcam setup is going to work is a Raspberry Pi. I'm using a Raspberry Pi Model 3B, I believe. It's an old Raspberry Pi I had laying around from a home automation project a few years ago. And for the uninitiated, a Raspberry Pi is basically a mini computer. It's actually smaller than this, but I bought a little case for it just to keep it somewhat contained and protected. But these things are very cheap. This, I believe, cost around $35 US. The basic premise is we're going to take this Raspberry Pi computer, install the Raspberry Pi operating system on an SD card. Once we have that done, we're going to boot into the Raspberry Pi. We're going to install a simple application that will take any webcam connected to the Raspberry Pi and create an IP camera from that webcam. If you don't know what an IP camera is, it's simply a camera that is accessible over an IP address, in most cases over a local network. So in our home network, there will be an IP address assigned to this computer, and we'll be able to access the camera connected to this computer by going to that IP address. From there, on the computer that we want to use to control our laser, we'll install an application that allows us to take that IP camera and create a virtual webcam on the computer, basically tricking the computer into thinking that the ThunderCam is plugged directly into the control computer. But it's not. It's instead a virtual webcam. This project does seem a little complex at the surface, but it is very simple, I promise you, and I'll walk you through the steps of how I did it. You may be wondering if it's worth it at all, but I'm of the opinion that anytime you can go wireless, it's worth it, because I don't have a static workstation out in my garage for my laser. Like, I don't have an old desktop or anything that is like always in place. And so I'm taking my laptop out there to the garage with me, and I prefer not to have to plug a bunch of cables into it just to control the laser. I already have my laser wirelessly connected to Lightburn via the IP address of the laser. So this is just an additional step. It wouldn't make sense to have the laser wirelessly controlled, but the camera hardwired controlled. This way I get to have both wireless and keep myself wire free. So with that, let's jump on into installing the operating system on the SD card. It's a micro SD card, and so to connect to it on my laptop, I'll need this adapter. So we'll plug the SD card in. On the computer, we have our SD card, and this I previously used for footage, but let me make sure I have nothing else in it. Yep, it's just a empty SD card. So we are going to go to raspberrypi.com/software, and that's where we're going to get the Raspberry Pi OS imager. So I'm on a Mac, so I'm going to download for Mac OS. I'm going to open that downloaded file, and then I'm going to install it in the applications folder on my computer. I will then go to applications and find Raspberry Pi imager. There it is. It will give you a warning that it's like an application you download from the internet. And then it's just a matter of choosing the operating system. We are going to select the first one. For storage, we are going to select the SD card that we just installed in the computer. Make sure it's the right one in case you have multiple, so you don't overwrite something you don't intend to overwrite. This is indeed the SD card I just plugged in. And now we'll go ahead and click write. It will warn you again that anything on that SD card will be erased. So make sure it's good, and then hit continue or hit yes. You will have to enter your password. It will ask permission to access files on the drive that we gave it permission to, so just say yes for that as well. And while that is installing, I'd like to take a quick moment to thank Thunder for sending me the ThunderCam for this project. I've been wanting a camera for my laser for quite some time, so this was a great opportunity to do something nerdy with it. Alright, after it is done, it'll say Raspberry Pi has been written to the media card that you selected, and now we can remove the SD card from the reader. So I'm click OK. And now we can close that, and our SD card is now fully formatted with Raspberry Pi OS. Next steps are to place it in the computer and boot it up. I need to go to my office, as that's where I have an external monitor that we can plug this into to do the remaining setup steps. So I will meet you in my office here in a moment. Alrighty, we are now in my office at my desk, and here is the Raspberry Pi. It's powered over USB, connected to HDMI, connected to wireless mouse, and I also have my office webcam plugged into here because I already have the Thundercam mounted in my laser. So I'm just going to use this for testing in here, but the same premise applies. So now we're going to boot it up by powering on the Raspberry Pi. When you boot up for the first time, it may be a little slow to get going, but just give it time and it will get booted up just fine. With our Raspberry Pi booted up, we can now download what we need. And quick apologies for literally recording my screen. I could not get a good Linux / Raspbian screen recorder app to work properly, so I'm quite literally recording my screen, which is like modern version of printing an email. So we will open the web browser. It should be on the dock in the upper left. This is a version of Chrome called Chromium, and we will search Cam2IP. The first link result is a GitHub page, and that's what we're after. I don't know what those images are. But this is the package we're after. It comes pre-built in a variety of flavors, and we are on a Raspberry Pi 3 32-bit, so I'm going to download that one. Once that is downloaded, I will click open, and from there I will extract, and I will extract it to my desktop and click open. Click extract, and there it is. So with that, I will minimize Chrome. I will open this up, and we are only after this file. It's the executable called Cam2IP. The rest is just text files, and we do not need them. So I will delete those. Alrighty, with that on the desktop, we can now give it a try to see if it's working. So I clicked this icon on the toolbar called Terminal. So in here, we are going to type cd desktop. That means change directory, and we're going to the desktop, which is where we put the file. And we're just going to type ls-a, which lists the files that are on the desktop. And as we can see, there is Cam2IP. So now we can give it a try and run it by typing /cam2ip. And we'll hit enter, and it says listening on port 56,000, which implies that it's working. So let's give it a try. We're gonna go to back to Chrome and open a new tab and type localhost 56,000. And there's the Cam2IP page. And as we can see, it gives us 3 different stream options: HTML, JPEG, and MJPEG. We're interested in the MJPEG flavor, which is what we'll use to provide a stream to our software on the host computer. But if we click that, as you can see, my webcam for my computer is showing, and you can just see how ridiculous this is, that I'm literally having to record my screen. With that working, let's go to the next step. So while this is running and works great, the problem is with it as it currently stands, we would have to start this program every time the computer boots. And our goal, once it's connected to the laser, is to not have a keyboard, mouse, or monitor hooked up to it. It's just going to operate in what's called effectively headless mode, where it boots up, starts what it needs to start, and you're none the wiser. So in order to do that, we need to set up a service to start this program on computer's boot and basically do what we just did for us. So I'm going to kill the app that we just started by pressing Control C, and that will stop the app. And now we can create a service file that the system will use to boot up Cam2IP when the computer starts. So this is the part where it gets fairly technical, but bear with me and just type exactly what I tell you to type, and it'll be easy. And you actually won't have to type most of it. You can copy and paste it most likely. So we are going to type sudo nano, let me move the mouse so we can see, /lib /systemd /system /cam2ip.service. And that's just going to be the name of the file, service file that we use to start this. So we'll hit enter, and it's creating the file and giving us an editor at the same time. So we're going to type the following, and I'm not going to narrate the whole thing, and I'll probably time-lapse over this. So again, the text you need will be in the description of the video. All right, with that typed, we can now save the file by typing Control-O, which will write out the file, and hit enter, and then we can do Control-X to exit the text editor. After that, we will type sudo systemctl daemon reload and hit enter. Then we will type sudo systemctl enable cam2ip.service. So with that last step, that enables the service to be registered with the system. Next up is to type sudo reboot, which will restart the Raspberry Pi. And when it boots up, the service should start automatically. So let's do that. And the system has restarted. I have not done anything, but I can notice that my webcam is on, so that's a good sign. So let's test it in the browser now. And we will go to the same address that we went to earlier, localhost 56,000, and there is Cam2IP. And once again, if we click on the MJPEG stream, there we are, right on cue. So with this running on boot, we no longer need the keyboard, mouse, or display, and we can take this out to the garage, connect it to our Lasers camera, and install the application that will receive this video feed on our host computer. Alrighty, over on the computer that we're going to be controlling the laser from, we need to install Open Source Broadcaster. This is an open source tool for creating, kind of complex stream. Like you can put multiple media sources in. We're just going to do one. The reason we're using this is because it allows us to pull in a IP camera and create a virtual webcam from it. So we're going to install this. It's cross-platform, so even if you use Windows, this should work well for you. I'm now going to go open OBS. Alrighty. Then when you open it for the first time, it'll have this auto configuration wizard. We are only going to be using it for the virtual camera, so go ahead and select that option. It's going to predetermine some resolutions for us. We're going to have to edit those, but that's okay. Alright. I'm going to full screen it. Now, basically this is a canvas that we can put various media sources on. We're just going to put the one though. But first I'm going to go into our settings and go to base canvas resolution. Here I'm changing the resolution to 640 by 480. I was under the impression that the ThunderCam was low resolution and that this was the settings it needed, but it was actually Cam2 IP on the Raspberry Pi scaling our camera down to that resolution. So I figured out how to change the width and height of Cam to IP, and I've updated the code in the description below in order to keep the full resolution of the camera. Next, I'm going to come over here down in the sources area, and I'm going to click add, and I'm going to click media source. I'm going to call this media source ThunderCam IP, and click OK. And then it'll have a properties window come up, and it wants to assume a local file by default, but we're not doing a local file, we're doing a IP camera. So over here, I have the camera pulled up locally. If we go and look at the stream, it is sitting over here on the laser, pointed up at the ceiling. And this is the stream we want to use. So we're gonna put that under input, and we're gonna tell it input format is MJPEG. It won't work if you do not do that. Usually it's expecting an RTSP stream. Worth noting, this IP address will be different for you. This is the IP address of my Raspberry Pi on my local network. You're going to want to log into your router and give this a fixed IP address, because otherwise if it's changing all the time, you'll have to come in here and change it all the time. So give it a reserved IP address. And so I've done that on mine. And I'm not going to show that because that's going to be different depending on which router you have. It'll be different for virtually everyone. So yeah, go ahead and set input to the IP address with the port /MJPEG and input format MJPEG. Then we'll click OK, and voila, it drops it on the canvas. And if we had multiple things, we could like reposition this, but we don't need to. We just need that. And with that, you're pretty much set in here. The only thing you need to do in order to use this as a webcam inside of Lightburn is start virtual camera. And it may need a password to do this the first time. There we go. So in Lightburn, now that we have a virtual camera set up, we can choose OBS virtual camera. And Lightburn will ask to use the camera. We click OK. And as you can see, there's our camera. So now I'm going to go ahead and set this up properly so that we can actually use the camera to position things on the canvas in Lightburn and give that a go. When you get the ThunderCam, it will come in this 3D printed enclosure with the camera, a long USB cable with the raw pin adapter, and a series of plastic mounting hardware with holes in the side that are meant for attaching zip ties to, which it also came with. So it came with everything you need to mount it. Because my installation is a little different with my intent on going wireless, this isn't going to be a full step-by-step, here's how to install the camera video, because that's already fully documented on Thunder's site and whatnot. I want this video to be how to set up local wireless control of the camera, so you don't need to be hardwired to your laser. Alrighty, down here is where some of the magic happens. So you want to be very careful when working in here because mains voltage is coming from the wall and going into here. I would actually normally recommend working with this off. Actually, I'm definitely going to recommend working with this off. So I'm going to go ahead and turn the laser off, cut power. What we need to do now is get the Raspberry Pi computer into the laser, and it's just gonna sit in here. You could mount it to the door where the fans are if you want. I may do that at some later date, but I am also very aware that there is nothing more permanent than a temporary solution. So the primary challenge we have is we need to get the power from the wall to the Raspberry Pi. And so I have this Raspberry Pi specific power cord that I had gotten off of Amazon with an inline switch to turn the Raspberry Pi on and off easily, and then it connects to a micro USB that powers the Raspberry Pi. And I need it to come in from the bottom of the laser because I don't want to drill a new hole in my laser, at least right now. But there are two holes here on the floor of this internal area. And so I'm going to have the power cord come up from the bottom of the laser into the laser. So this is going to plug in from the outside and come in from the bottom. So I'm going to disconnect the power for now. I am going to then carefully, so I'm going to plug the Raspberry Pi into the power cord and then the camera USB cable that we just routed into the Raspberry Pi as well. And then I'm just going to let that sit there. I'm going to close this up, and I'm actually not going to lock it yet because I need to make sure that there's power on the Raspberry Pi once I plug it in. So I'm going to take the wall outlet that just got very dusty on the floor. I'm going to take the wall outlet and plug that into my power brick or my power strip. And yes, so my power switch is off on the Raspberry Pi. So I'm going to flip that switch that currently resides underneath the laser. Again, not the most ideal, but powered on. I can see that the fan is spinning on the Raspberry Pi. So I'm going to lock that up and get out of here. With our camera and Raspberry Pi fully installed, we can go ahead and take advantage of the camera by positioning it to center over our bed. The 3D printed case that the camera module comes with has little knobs on the side that you can, once you get the camera positioned how you want it, you can tighten them. So I'm doing that now because that looks pretty good. Quick side note, I was having zero issues with the Raspberry Pi and the camera working together in all of my testing. But as soon as I mounted it in here, I was. And it occurred to me, the Raspberry Pi operates over Wi-Fi by default. And if you're putting a Wi-Fi device in a big metal cage, you're going to have issues with the signal staying strong from the wireless router. So we actually have Ethernet out here in my shop because we're nerds, and of course. So I may convert mine to hardwired Ethernet at some point because the Raspberry Pi also has a Ethernet port. But if you're having issues with connection, I would recommend, rather than installing the Raspberry Pi on the inside of the machine, inside of the laser, mount it on the back or on the side so that your Wi-Fi signal is not blocked on the way to the Raspberry Pi from your house or your access point out in your shop or what have you. All right, so with our virtual camera created and exposed to Lightburn, let's go ahead and give it a try. This video is not going to be a full how to set the camera up with Lightburn tutorial, as there's a dozen tutorials on how to do that already, and I was really just interested in showing you how to make a camera wireless for use with your laser. But not to be a complete tease, let's go ahead and do a quick cut test to show the benefits of having a camera integrated into your laser in the first place. So I have this, the best I could find for this example is I have this random piece of scrap that I don't know why I haven't thrown it away yet, probably because there's still an area or two right here that I've convinced myself is still good. So let's say we want to do something with this area without measuring it or taking a photo and then importing it into Photoshop or etc. Like we know that we want to do something right here and maybe even follow the curve of that. Let's say that's the case. So to do this, we're going to put the piece of wood on the laser bed. Let's say I want to do something right here, and you can see on my screen too. So first we position it. Now we need to update the overlay, and that will put a photo of our sample on the laser bed. And I am not very accustomed to drawing inside of Lightburn. I do most of my design work inside of Illustrator, so forgive my crude attempts at drawing here, but I'm just going to start this over because that's a terrible drawing. Let's try that again. There's my beautiful artwork. This is, completely silly, but it's the whole point. It's just to prove the point that you can use the camera to create artwork to a specific shape. It could be a guitar that a client provided you. It could be a MacBook or an iPad that someone wants engraved on, and you want to make sure your artwork is very, very pristinely placed for the material you're etching. So now with the fan turned on and my object placed and settings, I'm going to go ahead and go to the laser and start the job, remembering to make sure that start from absolute controls is selected. And as you can see, the laser hugged the line of what I drew perfectly. I could not imagine trying to create a vector shape to pinpoint an area like this without the camera system. And as you can see, the line hugged it perfectly like it did in software, like I did in the software. The camera image, that overlays your canvas inside of Lightburn is a little pixely because it is a fairly low resolution compared to the relatively large canvas you have inside of Lightburn. But this is like more than fine. Like it's gonna get you where you need to be, and you can be confident that it's gonna etch where you expect it to etch. And with something like a laptop or an iPad or something like that, you're probably gonna go past the bounds of it anyway. You just want to make sure it's centered and not gonna be off. So yeah, I'm very happy with this result in this project, and I can't wait to use it on a real project. Alright, so there you have it. Now I know this video is a fairly complex tutorial for what is otherwise a woodworking, laser, and maker channel, but hopefully you still found it useful and see the benefits of having a wireless camera in use for your laser. If you have any specific questions, I'll do my best to answer them down in the comments. And if you like this video and would like to see more like it in the future, I sure would appreciate if you gave this video a like and subscribe to my channel. Otherwise, until next time, cheers! Let me just say, you want an ab workout, do this while trying not to lean on your gantry. That's a workout for you.